Okay, so the first one up here, LYA Corporation plans monthly advertising expenses as 21% of the previous month's profit. How much will LYA spend on advertising the month after achieving an $850 in profit? So we have the 21%, which is 21 over 100. Now remember, both numbers there represent something. The 100 represents it's called the base amount. It's the whole thing or the beginning amount. In this case, what is the whole thing or the beginning amount? Well, we have two things we're talking about. We have advertising expense and we have profit. One of them is a portion of the other. Is the profit a portion of the advertising expense, or is the advertising expense a portion of the profit? Yes, the advertising expense is a portion of the profit. So the profit is the whole thing, and the advertising expense is the portion, the piece out of it. So then on the other side of things, we have the 850,000. Does that represent the advertising expense or the profit? Profit. So then we are asked to, how much will they spend on advertising? Find the advertising expense. So we cross multiply and divide. What are we going to get? At 178,500 is what they're going to spend on advertising for that year, for that month, sorry. That's my budget. Yes, it is. But you got to look at, like television ads, and a lot of those are, 30, 40,000. It all depends on what it is. Like in the Super Bowl, I mean, those are like 5 or 6 million for a 1 minute commercial. Just played once. Yeah. Yep. Yeah. Okay, so for the second one here then, Pat Sams pays 6% sales tax on a new car. How much was the car if Pat paid $1,740 in tax? So we have 6% here, 6 out of 100. What does the 6 represent? Sales tax. The 100 represents bless you, the price of the car, right? The sales tax is figured as a portion, a piece of the price of the car. On the other side, we have the 1,740. What does that match up with? Is that the tax or the price of the car? That is the tax. Come on now. So we cross multiply and divide. 100 times 1,740 divided by 6 gives us, is that 29,000? So that car cost Pat $29,000. Any questions on those simple percent questions like that? Okay, so where we left off on Tuesday was talking about what happens if they aren't a simple percent question. What happens if it's something like this? Peyton must pay a 12% handling fee on all orders. Find the total cost of an order for $4,500 in merchandise. So here we have that 12%, 12 out of 100. What does the 12 represent? The handling fee. What does 100 represent? It is the cost of the merchandise. Is that the same as the total cost? No. That's the cost before the handling fee. The total cost includes the handling fee. So now on the other side, do we have either one of those numbers, the handling fee or the cost of the merchandise? Yes, we have 4,500 in merchandise, the cost of the merchandise. So now before we cross multiply and divide here, if we do that, what we're going to get is the dollar amount of the handling fee. Is that what we're looking for? No, we are looking for total cost. If I know the handling fee, can I use it to find the total cost? Yes, I can. So let's cross multiply and divide. 12 times 4,500 divided by 100, which is going to give us, what, 540? $540, okay. So that is the handling fee. So we have to get the total cost. We're going to take the 4,500 plus the $540 to get a total of $5,040. What we have there, this is of course the total cost. This was the handling fee. And this number up here was just the merchandise, 4,500. When we deal with percents, every item in a problem is described by two numbers. In this case, we had the dollar amounts that we show over there, but each of those items is also described by a percent. We said that 100% described the cost of the merchandise, and that 12% described the handling fee. Well, over here, we took the cost of the merchandise plus the handling fee to get the total cost. We can do the same thing over here. 100 plus 12 is 112. What that's telling us is that cost, that total cost, since it's the full price plus 12%, that total cost is 112% of what we started with. So what we could have done was found 112% of the 4,500. And when we cross multiplied and divided there, that would have given us $5,040. Any questions? Okay, well, let's take a look at one slightly different. Tim receives a 19% discount on items purchased. How much does Tim pay for items priced at $240? Well, again, we have that 19%. What does the 19 represent there? The discount. 100 represents full price, right? On the other side, the $240 does represent the full price. So if we cross multiply and divide here, what we're going to find is the dollar amount of the discount. Now again, is that what we're looking for? No, but if we knew the discount, can we use it to find what we're looking for? Yes, we can. So 19 times 24 divided by 100 is 4560. So to use that to find what we're looking for here, we would take the $240, subtract the 4560 to get $194.40 is what we paid, is what Tim paid. Now again, we can look at this in terms of that being the dollar amount, but also the percents. The 240 was full price. The 4560 was the discount. The 194.40 is what was actually paid. Well, on the percent side of this, we said that 100 represents the full price and 19 represents the discount. Is this going to be 119% down here? Say no. Why not? Yeah, discount is subtracted, not added. It's 100 minus 19, which is 81%. So if we had wanted to, rather than finding the 19% and subtracting, we could have found 81% of the $240. And when we cross multiplied and divided there, we would have calculated $194.40 directly. Now, in both of these last two problems I did, it makes no difference whether you found the amount, then either added it or subtracted it, or if you adjusted the percent and used that adjusted percent. But as we saw at the end of the class on Tuesday, there are times where we can't do that. If we're given the ending amount, we can't just use the percent. We have to use that adjusted percent. For example, let's say that after a 15% discount, Pat pays, let's see here, $2,040 for, we're just showing my total lack of creativity, for items. What was the full price? Well, here we have 15%. The 15 represents the discount, right? 100 represents full price. We're looking for the full price, right? We're looking for this number. Do we know the discount? No, we don't. The 2040, that's the price after the discount. We don't know either one of these numbers over here, so this isn't going to work. Is this a percent increase or a percent decrease? Does that 15% add to the price or does it reduce the price? Reduces the price. So this is a decrease. If it's a decrease, we take 100% and subtract that percent decrease. 100 minus 15 is 85%. So what that is telling us is if we look at 85%, 85% is the price after the discount. 100% is the full price. So that 2,040 is the price after the discount. It goes up there. So now to solve this, we're going to cross multiply and divide. 100 times 2,040 divided by 85. Which gives us $2,400. So full price was $2,400. Does that make sense? You think so? Okay. I'm going to ask you guys something a little bit different. Frankie receives a 9% discount. How much does Frankie save on items that Frankie pays $2,730 for? I'm going to give you a couple minutes to try that in your notes. Okay, so this is a percent decrease problem. So since a percent decrease, what we're working with is 100% minus the 9%. It's going to give us 91%. The 91 represents the price after the discount. The 100 represents full price. The 2,730 is the price after the discount. If we cross multiply and divide here, we get $3,000. That is the full price. Is that what we're looking for? No, we still do have to do 3,000 minus 2,730. You get $270. That is the discount. That's how much Frankie saved. Now, you might be wondering, well, if I had to end up subtracting anyway, why couldn't I just find 9% and go there? Well, that 9% is not based on the 2,730. That 9% comes out of the 3,000. If you tried to find 9% of 2,730, you're going to end up being like $8.10 off. Okay. So now that we've looked at this percent increase and decrease, there's a couple of applications that I have to show you. One is markup. Markup goes off of, now we're going to talk about markup based on cost. If you were to get into a business or merchandising class, you'll see that there is a markup based on the selling price, but we're going to do the markup based on cost. So let's say that Pete purchases items for $80 each. Has a 30% markup How much does Pete charge? So here, again, we could find that 30% and add it on. But we have 100% represents what Pete paid for him. In other words, that's Pete's cost. We've added 30% to it. That 30% is the markup. If I add those together, 100 plus 30 is 130%. That is the amount that Pete is going to charge when Pete sells them to customers. So if I want to find how much Pete's going to charge, it's best if I just find the 130%. Of course, the 100 represents the cost. $80 is the cost. Cross multiply and divide. 130 times 80 divided by 100 is 104. So Pete's going to charge $104 for those items. Let's say after a 40% markup, Peyton charges $294 for an item. How much did Peyton pay for it? I'll give you a minute, your notes, try to figure it out. So again, Peyton's cost was 100%, adds a 40% markup. So what Peyton charges is 140% of cost. So that set up as 140%. The 294 is what Peyton charges. So that represents the 140. Cross multiply and divide 100 times 294 divided by 140 is $210. Any questions on that? Okay. Well, another application of interest or of percents is simple interest. Simple interest is basically that. It's the simplest way we can calculate interest. In simple interest, interest is only calculated on one of two events. One, you get to the end of the term of whatever the account is, or, excuse me, there's an action on the account, like a deposit or a withdrawal, payment or withdrawal. The amount of interest which we're going to use the letter I for, is equal to principal times rate times time. So in this formula, I is the dollar amount of interest. P is the principal. That's the starting amount. R is a rate. That's a percent as a decimal. And T is time in years. So come on. Alex invests $3,000 at 6% for 3 years. How much interest is earned? So the amount of interest is equal to PRT. What's the principal? $3,000 is the starting amount. What is the rate? It's 6%, but we're going to write it as a decimal, so it'll be 0.06. And what's the time? 3 years. Bless you. So we multiply that out. 3,000 times 0.06 times 3 years. Is that $540? So that's the amount of interest, $540. How much will Alex have at the end of the 3 years? Well, all that's asking us to do is what? Perfect. Take our original 3,000, add the $540 to it. Alex is going to have $3,540. Now, simple interest, like I said, is the simplest way to calculate interest. Unfortunately, it's not a common way of calculating interest, at least not in investments, at least, and not for 3 years. A bank is not going to want money sitting there for 3 years without the interest being calculated on it. Simple interest is normally going to be for shorter term things. In business, it's not uncommon to borrow money on short term. Let's say you're going to borrow $3,000 at 9% for 3 months. How much do you repay? No, you can't skip off to Mexico and repay nothing. We're going to find our interest. How do we find the interest here? What's our principal? The 3,000 again. What's our rate? 0.09, the 9%. Now our time, remember we said our time is always given in years. Well, here we have 3 months. So to express that in years, we would have to 3/12. So there's 12 months in a year, so it's 3/12 of a year. So if we calculate that out, 3,000 times 0.09 times 3 divided by 12, $67.50. That's the interest. Does that answer the question? No, how much do you need to repay? That'll be the 3,000 plus the $67.50. That's going to be $3,067.50. Any questions? Okay. Normally on things that are longer than a few months, the bank does something called compound interest. So to look back at that first example, we had $3,000 at 6% for 3 years. They wouldn't do that simple interest. We might do, we're going to do $3,000 at 6% compounded quarterly for 3 years. So the key word there is the compounded quarterly. What that means is every quarter or every 3 months, the interest is calculated and added into the account. So let's look at quarter 1. Calculate the interest and find the ending balance. So our interest for quarter 1 will be the $3,000 times 0.06 times 3/12 or 1/4, however you want to put it. What's that going to give us? Is that $45 in interest? So that gives us an ending balance of $3,045. Well, for quarter 2, our principal isn't $3,000 anymore, it's $3,045. That's going to give us, what, $45.68? What happened there? Okay, so the example I want to show you, what we just did is if you put that $5,000 away once and let it sit there, don't put any more money away. What I want to show you is this. We're going to start at 21 just because we can. And we'll go up to that 67 age again. So there's 67. Let's deposit that $5,000. We'll make it look pretty here. So we're going to deposit $5,000 a year. And we're going to assume that 10% interest again. So at the end of the second year, you have $10,500. So again, we're depositing $5,000 a year, starting at age 21. Anybody want to guess at how much you would have at 10% interest at age 67? Bless you. Any guesses? About 4.3 million. 4,359,000. Yeah. That's a decent chunk of change. I'm guessing you could probably survive off of that in retirement. Don't know. You could probably blow through 4 million. You have faith in yourself, you can waste it. Okay. Well, actually, there have been a lot of people that have won the lottery that have, yeah, 5 years later are flat broke. So, yeah, everybody wants a piece. Now, let's look at the difference here. What if you decide you're going to wait? Pick an age. What age do you want me to start at? 28? So you're going to wait till you're 28 to start. Anybody want to guess? It's going to be around 2.2 million if we wait till you're 28. Now let's do this. Since you picked 28, let's have some fun with this. Let's say somebody else starts at 21 and saves until they're 28 and says, you know what, I'm not going to save anymore. So this person here, you starting at 28, you saved for 40 years, from 28 to 67. This person saved for 8 years and is never going to put another penny away again. You end up in the same spot, 2.1 or $2.2 million, because of the compound interest. That first 8 years of investing when you start to work is worth more than the rest of your life is. That's depressing, yes. The moral of the story is start now. If you wait 5 years, you've lost pretty much close to half of your retirement versus starting now. Okay, there's my depressing thought for the day. I'm going to have to go home and cry myself to sleep every night after I do that example. So anyway, let's take some time now to review for our test. First thing I want to do is I want to list the concepts that we have to know. We need to know percents. Of course, in percents, you're going to have to convert from a percent to a fraction, from a fraction to a percent to a decimal back to a percent. Then you're going to have to do all those calculations and word problems that we've just been doing. I know you guys are starting to love word problems by now, right? Did they hurt as bad as they did 11 weeks ago? They do? I'm sorry. Yeah. That is a very good question. There will be a 4th unit test. That's the second to the last day of the class. You'll get that one back on the last day so that you can do corrections on it if you want to. Depending on how the schedule goes, if there's time, there is a test that is the whole course. That does not affect your grade. Well, what it is that's to evaluate how effective the class is, not how much you've learned. So if I look at that and everybody bombs that test, that tells me that next semester I got to do something different because you didn't learn much in the class. What the deal I usually make with people on that one is it can help your grade, but it can't hurt your grade. Let's say you're sitting at a C and you get a B on that test. I'll average them together and raise your grade. If you're sitting at a C and you get a D on that test, I'll pretend that test doesn't exist. Okay, so you've got to know the percents up and down. Then you have to know how to work with these algebraic numbers. Algebraic numbers, otherwise known as polynomials. So that is problems like 5x squared minus 7x plus 2 minus 8x squared plus 9x minus 13. How would we do that? Yeah, we write it out just like any other problem. And remember, we are subtracting. So then it's 2 minus a negative 13, which is 2 plus 13, or positive 15. Negative 7 minus 9, which is negative 7 plus a negative 9, or negative 16x. 5 minus 8 is negative 3x squared. Any questions?
I thought you changed everything.
Okay. One option you can do is, since it's subtraction there, you can change it to plus the opposite. Kind of like what I did here, I changed that to plus the opposite. So you make this plus, then you change the sign of everything here. This becomes negative, that's positive, it becomes negative, that's negative, so it becomes positive. That works. Yeah, then you can add, subtract. Okay, other problems you'll need to be able to do is stuff like this. 7x minus 2 times 5x squared plus 8x minus 3. How do you do that? Well, first you keep my stuff from disappearing. We use the variation of FOIL. 7x times 5x squared is 35x to the third. Good. 7x times 8x. 7 times 8 is 56. X times x is x squared. 7x times negative 3. Negative 21x. Good. Now when we go over to the negative 2, I'm going to drop down a row so I can line things up. Negative 2 times 5x squared. Negative 10x squared. So I'm putting it under the 56x squared. Negative 2 times 8x. It's negative 16x. I put that under the negative 21x. Negative 2 times negative 3. Positive 6. Now I'm going to combine. Well, there's nothing to combine with the 35x to the third. 56 and negative 10 makes 46x squared. Negative 21 and negative 16 makes negative 37x plus 6. Any questions? You will also have to solve equations. With fractions and or decimals. Equations that might look like this. 3/4 x minus 2 1/2 equals 5 1/4. What would we do there first? Careful. Yeah, it's minus 2 1/2, so we add 2 1/2. So 3/4 x equals, that's 7 3/4. 5 1/4 plus 2 1/2 is 7 3/4. And then divided by the 3/4. So x equals, now you guys can do this on the calculator if you want to. We're going to do the improper fraction. 7 times 4 is 28, plus 3 is 31/4. Take the reciprocal, so that's going to be 4 over 3. It's now times. The 4's cross cancel, give me 1 and 1. So that's 31 over 3, or 10 1/3. You may have equations with parentheses in them, like this. Tell me what to do here. Distribute the 5. Very good. 5 times 7x. 35x. 5 times negative 3. Negative 15. And then we still have the positive 2. Now, before I go over to the other side, I'm going to combine what I can here. What can I combine? Negative 15 and 2. So that's 35x minus 13 is what that becomes. Over on the right side, what can I do? Distribute the 4. Good. 4 times 3x. 12x. 4 times 1. 4. Then I have the negative 2x there. What can I combine there? Make my 2 come back. What can I combine here? 12x and negative 2x make 10x, and I still have the positive 4. Now what? I gotta get rid of one of my x's, so I'm gonna take away the smaller one, which is the 10x. So 25x minus 13 equals 4. And then add 13. So 25x equals 17. And then divide by 25. So x equals 17 divided by 25 can either be listed as 17/25ths, or it can be listed as 0.68 as a decimal. Either way is fine. What do you think? Not so bad? You do operations with decimals. The adding, subtracting, multiplying, and dividing isn't such a big deal. But the one that usually confuses people is when I do something like this. Find 0.004 to the power of 6. If you punch that in your calculator is most likely going to tell you something strange like that. It is the correct answer, but it's in scientific notation. That is saying 4.096 times 10 to the negative 15th. That's what that means. If you work with that, of course, if you know your scientific notation, that just means move the decimal point 15 spots to the left. Or if we look at this, how many decimal places are here right now? There's 3. If I take that to the power of 6, I'm going to get an answer that has to have 3 times 6, or 18. Of course, I wrote those way too big. There's no way I'm going to get 18 across there. Let me try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 decimal places in my answer, right? So that 4096 goes at the end, and I fill in zeros. By the way, 4 to the power of 6 is 4096. That's where that 4096 comes from. I'm not going to be quite that mean to you on the test, but there's a good chance if you try to punch that into your calculator, you're going to get scientific notation. So make sure you're aware of how to figure that out. That's really it for the test. Does anybody have any specific questions they want answered? Yes, I will have it submitted probably early Tuesday morning. So anytime after like 7:30 Tuesday, you can take the test. There is a new quiz that is due for tomorrow yet. 11:59 p.m. And there is a new homework due for next Tuesday. Tuesday's our test. I'll let you guys have our last 30 minutes here if you want to work on homework or quizzes or anything else. I will be here till 5:20.